Okay. And I also like that live transcript. How do I? Okay. I think we're all ready. So after we ended on Wednesday, feels like, I don't know, feels like a long time ago for some reason. I posted some more instructions on how to install R in RStudio. And I moved that due date till Monday at midnight. Okay, so you've still got time to set up. And the instructions are hopefully a little bit helpful. But if you're finding that it's giving you trouble somewhere along the way, then you can stop me at the end of class and we can work through it together, or just let me know over the weekend and we can meet up at some point and get it all set up. I saw there's quite a few submissions already, so I'm really pleased with that. So nice work. I also posted, you'll have seen probably, well, we've got our first lecture video on YouTube, right? But also I posted the notes from last day. So this is kind of what to expect. They don't look nice or anything, but there they are, right? So every day I'll post those notes. And then for today, I cheated. Well, it's not really cheating, hopefully. It's plagiarism, but it's less than 20% of the book, so I'm allowed to do it. So I think that's the rule. I should probably check on that. But anyways, so what I've done is I've just extracted from chapter 1, just the key points that I want to talk about today. Of course, if you're interested in more kind of terminology and kind of deeper thoughts around this, then of course it probably is in the textbook, so you can check out the textbook. But these are the things that I wanted to talk about today. So I stole them and put them in a document so that it would be a little bit easier for us. But we're gonna, blab about this. And there are a couple of things that I've included just so that we can talk, kind of think about some things. So that's posted there. But as we go through our notes, I'm going to pull in these chunks and write around them. So you don't have to print these off if you're printing off notes or anything. It'll be in our full notes later. But just so you know what to, in the first week, we're just getting used to how we all work, right? So, okay. Oh, and I can't remember if I had already posted the link to that installing R in RStudio video. It is old, but maybe useful. I don't know. We'll see. You guys can let me know. I don't think things change that much. So let's go ahead and start today. So just as a reminder, the markdown test, which is really just, in this case, test means practice. Have you guys seen those videos where they talk about how confusing the English language is? Anyways, here in this case, the test means practice, as opposed to a test of your knowledge. Yikes, right? Pardon?
That's annoying.
I know, right? Yeah, she points out all these random things that you don't really think of. Anyways, it's pretty interesting. So now I pay more attention to it and it's even more annoying. All right, so the Markdown test document is due on Monday at 11:59. Now, I always make things due at midnight, but midnight is confusing because that's the beginning of the next day. So 11:59, that's your deadline. Okay. So late at night. But like I said, I've seen a lot of submissions there, so I'm not too worried about that. But if you're still working on it, then catch me maybe at the end of class and we can get you sorted out, or sometime on the weekend is fine too. All right, so chapter 1, like I said last day, is kind of like it's more of an appetizer. It's supposed to get you excited for all the things that we're about to learn, and there's not a whole lot going on in there, but it might be nice to know what we're about to learn. So let's start talking about, now I want to see here. I actually only want to grab this for a little bit. So I'll slice it and dice it in here. Okay. So we're focusing on business analytics because, well, it covers a broad area, of course, and most likely you'll be in some sort of financial role, something, right? It's always about the money, right? And so we're going to focus on business analytics, but really all these analytics tools that we're going to develop could be applied to any field, right? But kind of the money-making fields are the most important, right? Or at least the most sellable. So business analytics, really, it's just taking data, so taking information and learning from it, right? And whether we just want to learn what's happening right here, right now, right? Or if we want to use that data to be able to figure out what might happen in the future, right? Those would all fall under the analytics umbrella, right? And so, oops. Could be for current data, right? What's happening right now, right? To see what is happening right now, right? Or the other option, like I said, is if we use that data that we have, right? So use existing data to try to figure out what's going to happen, right? To predict what's going to happen. Okay. So, or we use existing data to predict what might happen in the future. To predict what might happen in the future. I'll clean up that future. It deserves to look nicer. There. So kind of same thing, but if you kind of step back, right? One's a snapshot of right now or what has happened, and one we're kind of going a little bit beyond that, and we're saying, okay, well, what if we want to predict the future or do our best at predicting the future, right? And that could be a little bit more advanced, right, in terms of the tools that we need, right? And that's what we're about to see. They lay it out in this section. Okay, so of course, now the goal is usually just for decision making, right? And why else would we want to predict things? Well, it's to be able to make a decision. Should I buy this stock? Should I not buy a stock? Should I bet on this? Whatever. That's buying stocks, right? Betting, I guess. I don't know. Decisions. Should I buy this machine or not? Right? So it's all about making decisions. Now, I didn't really want this whole blurb, but it didn't hurt. The key thing is the last sentence that I wanted to point out here. So we can use data. Insights is kind of a buzzword, right? We love saying insights. We use data for these key insights, and the more you can kind of bake that in, the better, I guess. So we can aid decision-making by creating insights from data, by improving our ability to more accurately forecast for planning, right? So if you own a car lot, for example, how many cars should you bring in, blah, 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 right? So kind of basic stuff, but this is the one that I wanted to, this example is the one I brought it in for. So it says, a study based on a large sample of firms that was conducted by researchers at MIT's Sloan School of Management and the University of Pennsylvania concluded that firms guided by data-driven decision-making have higher productivity and market value and increased output and profitability. Okay, cool. I reacted to this a little bit, and I was kind of put off by it. It makes sense, and I'm on board. But what's one thing that we can think about? Okay, so a firm that is able to hire someone who can make decisions using data, that's probably going to be a bigger firm, right? With higher productivity and market value. But then it says increased output and profitability. So they did look at that, but just those kind of things, when you react to them, just kind of sit down and say, okay, well, why am I reacting to it, right? And that's going to take practice to react to something, right? But that was my gut reaction when I read this little blurb. I thought, well, yeah, but also the firms that are able to hire these people with these skills that cost money to hire, which is a good thing for you guys, right? It makes sense that they would have higher productivity and higher kind of, because they've got all the resources, right? And so it's an interesting statement, I guess. And it's true, it's in a textbook, it's true. So it's definitely working in your favor. But I did react to that, and I'm curious. I didn't look at the actual study because I'm lazy that way. I should have, to see if they addressed it, right? These likely having more money firms, did they take that into account? I'm curious. I don't know. I didn't look into it. Maybe not that curious. I didn't look into it. Okay, so we just need to be critical, I guess, is what I'm trying to say with this little blurb. And it's also a fun thing to read when you're just starting this study. Okay. So let me bring in this next thing. So what's happened is that business analytics have been broken up into kind of 3 categories or phases, right? Where the most simple version of business analytics, we call it descriptive analytics. Now, having worked in market research and I think I was a data analyst at some point. I don't know, the titles are all different, but anyways, so having worked in that environment, I'll tell you this, descriptive analytics are pretty much all you'll really ever need to do, okay? You might see some predictive analytics, but pretty much everything that people want will be descriptive analytics, right? And then you might head into predictive analytics. And then we talk about prescriptive analytics, which is beyond the scope of this course. I'll tell you what it is, but you're going to need more training for that. Prescriptive analytics is when you prescribe some sort of treatment, right? So based on a prediction, and I've got little definitions later, but so you make a prediction, and if the prediction is that, you know, they've got an example, and I brought it in, I think. If a prediction is that you're going to sell 20,000 cars of some model, then you don't bring that car in because it's not enough, right? They've got a better example, don't worry. I don't make up examples on the fly. It's not my forte. But anyways, so that's why I bring them in earlier. Okay. So here, I'll bring in this whole kit and caboodle here. So descriptive analytics is just anything that's happened already. So existing data, right? And I'm going to bump this over and write that here. So it's for existing data. Descriptive, if you think about the word, right, you're just describing what's happening there, right? What's the mean? What's the standard deviation? What's the count in each category, for example, right? You're just looking at the data and you're describing what's happening there and maybe summarizing, right? So some examples are data queries, right? Where we pull existing data that satisfies some criteria, right? Just writing reports. Reports have to use existing data, right? Can't write reports on future data. Descriptive statistics are things like the mean, the median, the interquartile range, blah, blah, blah. We'll get to that in chapter 2. If you've had some sort of stats course before, then those might ring a bell, but we are going to review those in chapter 2. So descriptive statistics, data visualization, including data dashboards. So at one point, I did start my own reporting business, and because I wanted to do streamlined reporting. And this was when Knitter, which is the package that we're using, just came out. And so no one was doing it. And I thought, you know what, people are generating all these reports and they're always the same. So why not have it be dynamic, right? Dynamically generated. And people thought, oh yeah, that's great. How about a dashboard though? Because then everyone wanted dashboards. I'm like, fine, you can have a dashboard. Everyone wants a dashboard. So maybe we'll try our hand at making a dashboard because it is pretty fun. And if you've logged into basically any website now, you log into your TELUS account, let's say, it's like you've used this many minutes and you have sent this many messages, right? Blah, blah, blah. And it's all compressed into one dashboard. But those are just descriptive statistics, right? Just summarized on a nice one pager, and that's a dashboard. So it's nothing crazy. Some data mining techniques. I would think that that's more of a data query, but you are scraping data like you're collecting data. And then they say, and basic what if spreadsheet models. Now, I don't actually know what a what if spreadsheet model is. Sounds like a business thing to me, but I can imagine, right? You've got a spreadsheet. What if it rains tomorrow? What if it doesn't rain tomorrow? That kind of thing, I'm guessing. So this is all descriptive analytics. We can just lump up by thinking, okay, you take existing data and you're just describing existing data. All right. Predictive analytics takes it a little bit further, right? And so now we take past data and we construct models, right? And models don't capture the exact activity, right? But they're meant to kind of capture the flow of the activity, right? And so we'll start and we'll build some models, some basic models in this course. I think we get into linear regression where we fit a straight line. We might get into logistic, anyways, we'll see. So we're constructing from past data and we're using it to learn about what might happen in the future, right? Now, the future, of course, time-wise, there's a time component, but it could also just be, what if we collected other data in another country, for example, right? And so I'll point that out if it comes up, but otherwise future is just a time thing, okay? So for example, past data on product sales may be used to construct a mathematical model to predict future sales. Fair enough, right? And you can see why that would be beneficial, right? So use existing data to predict future data. And then, of course, the prescriptive analytics is the most advanced type of analytics. And like I said, it is beyond the scope of this course. I am kind of assuming it gets touched on in another course that you guys do. Maybe, maybe not. I'm not familiar enough yet. But I'm guessing maybe Bevan would teach it. He seems like he would teach it. But anyways, so we're not going to get into prescriptive analytics, but let's talk about what it is. So prescriptive analytics is really just when you have some course of action that you're going to take after you've made your prediction, right? And so some sort of decision is made after you've made your prediction. Okay. So a decision is made based on the prediction. So these build on each other, right? So we can use the term forecast or prediction interchangeably, right? And so predictive models, which is the one that we were talking about earlier, predictive models provide a forecast or a prediction, but do not provide a decision, right? And so, but when we combine it with a rule, right? So some sort of decision rule, then it becomes a prescriptive model. And here is the better example than the one I came up with that was really bad. So for example, we may develop a model to predict the probability that a person will default on a loan. Sounds reasonable enough. People have definitely built those models for banks. So if we create a rule that says if the estimated probability of default is more than 0.6, so 60%, we should not award a loan, right? So now the predictive model, which predicted a probability of 0.6, and the rule that said that anything below 0.6, or maybe it predicted 0.5 and anything below 0.6 doesn't get the loan, right? And so, or above 0.6, I guess. Yeah, above 0.6. Below 0.6 is better. So that's prescriptive analytics. So we're not going to get there, but you can see that it's not that far. You just need to be kind of topic specific, right? So it depends on who you're working for to be able to make those decision rules, right? And so let's see here. Oh yeah, so these types of prescriptive models that rely on a rule or set of rules. So it could be, okay, if this happens and this happens and this happens, so it could be a chain of events, but those are rule-based models. Okay. Good. Just to give you an overview, well, this isn't something to learn, but it's more information for you to see in terms of the chapters in this textbook. I had one complaint about this graphic. Man, am I picky or what? So I had one complaint about this graphic. What do you think it is? Any guesses? I know, so picky, right? I would have loved to see some lines here. It's really hard for me to see where this dot belongs. So picky. I know, but when we're showing graphics, right, the goal is for them to be easy to read. So, and this, I think, fails. It's okay. Past the whole editing process, so I guess it's okay. I would have liked better lines than the one I'm able to draw, right? So here, right, because they've got, you know, the descriptive, and like I said, most of what we're going to be doing will just be descriptive statistics, and a lot of that just kind of describing what's happening with our data, right? And then we'll move into predictive statistics for, well, it goes as far as chapter 11, but we actually end, well, if we get as far as Joe's hoping, he wants to go to chapter 9, and I'm thinking probably chapter 8, but we'll see. We'll see. We're aiming for 9 here, which means that we'll end just before prescriptive analytics, right? But it's there if you want to read on. But so here, yeah, that was my one complaint. I want lines on here, or at least, I don't know, something to help me read. So the first, I guess, 6 chapters focus on just descriptive analytics. Okay? So that's where we're going to be spending our time. And then we get into things like linear regression. Linear regression is when we fit a straight line. So if we have data, so imagine a scatter plot, right? So you've got your data, a nice graph, and it seems to follow a straight line, right? It could be modeled by a straight line. Then we build a linear model to make future predictions, right? And then we follow that line and we can make future predictions. Then we move into time series and forecasting. So time series is a special case where time is one of the variables that we're interested in, right? So what's going to happen in the actual future, that's where it gets confusing, right? We talk about time future and just future data points that we might observe, right? So maybe it's in a different place or where time has nothing to do with it, right? Usually it's a different place, different store, different business, right? And then, so we do data mining a couple of times. So in chapter 5, we do descriptive data mining, but then we get into predictive data mining as well. So we'll come back to it a little bit. Okay. And then I'm guessing Bevan takes over and teaches you this stuff. I don't know, in another course at some point, maybe. I don't know. I'm not the boss. I'm just here for this one. So this is the fun one. So good. So that kind of gives you an overview of how far into things will go and what you could do after. Here's just a little fun example. They have a lot of fun examples in the textbook. But so I guess Kroger, which is a grocery store, right? I think. I'm not that familiar with the States, but anyways, oh yeah, it's a grocery chain. It says right there. Read the question, Emily. So Kroger is the largest retail grocery chain in the United States. It sends over 11 million pieces of direct mail. That's insane, but whatever, to its customers each quarter. What? 4 times per year? Also insane, even more insane. It's 4 times insane. The quarterly mailers each contain 12 coupons that are tailored to each household based on several years of shopping data obtained through its customer loyalty card program. I think we've streamlined that a little bit more. The checkout lady at Superstore just convinced me to sign up for the PC Optimum app, and it has coupons tailored just for me. I get extra points for tomatoes. I get extra points for tortillas. It's good. So anyways, so they're already doing it way better than Kroger mailing out 11 million pieces of paper each quarter, but you get the idea, right? It had to start somewhere, right? And you'll see why they kept doing it when we get to the $10 billion. That's worth it, I think. Right, and so they figured out what people are buying, and then they're sending out these direct mailers. So Kroger has been able to realize a far higher redemption rate on its coupons. Fair enough. If it is something that I'm actually going to buy, I'll probably use it. Right, in the 6-week period following distribution of the mailers, over 70% of households redeem at least 1 coupon, leading to an estimated coupon revenue of $10 billion for Kroger. That is a lot of money. And so I'm guessing it's worthwhile to do these 11 million pieces of mail, but better to develop an app and just have it done in the app, I think. Especially if you get to see those that revenue still. All right. Oh, I did have a sticky issue with this one too. More of like a thinker. I'm not upset by any of these. It sounds like I am, but I'm not. I just like to be critical of all these things that I read. Oh yeah. Here's my sticky issue. I just remembered what it was. Maybe you can think of something else too, but so they're saying over 70% of households redeem at least 1 coupon. What if it wasn't tailored to that specific household? What if they just had 12 coupons standard that they sent to every household? And I wonder what the coupon revenue difference would be. Right, that's also a research question. I'm not sure they ever did that. You'd have to do it to try it out and see, right? But anyways, just something to think about. All right. So I don't know about you guys, but for me, I haven't had to deal with big data that much. In fact, just once or twice. And it was just for practice. It wasn't even for real. Like the big data sets that I've had to deal with, they were big. Like you can't use Excel big. Can't use Excel big. But R handles it fine. right? So for me, big data is kind of this mythical unicorn. And the textbook even says that there's no definition of what is big data because it depends on a number of factors. So for us, we're not really going to specify that much, whether it's, big data or little. Is it little data? Big data, little data, large data, small data? Anyways, it doesn't matter. The tools stay the same, right? It's just how much data are you applying it to, but that doesn't really matter, right? And so for us, what I want to kind of highlight, in case you're feeling like, I don't know big data, that's okay. It's the same. So don't worry. So it is a thing, and it is something that we need to learn how to deal with, especially kind of accessing big data and kind of retrieving it, but that's different. So the key here is that the key to analytics is that it provides useful insights and better decision-making, blah, 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 using the data that are available, whether those data are big or small, right? And so here we use the same tools regardless of sample size. I guess you could say that. Big data has a huge sample size, regardless of sample size. Yeah. The big data that I've dealt with, so I worked for First West, which owns Valley First, Envision Financial, and Island Savings. And so we were trying to build this attrition model. And so you want to try to pick up clients or members before they leave the bank, right? You want to try to pick up on cues in the data that are going to tell you that this person is about to close their account. Now, there are some key factors, of course. Is the account idle, right? Have they been making withdrawals? Have they been making deposits? There are some important things. But then you have the problem of, okay, well, there are actually very few people who, so remember, credit unions have free accounts. So banking is free at a credit union. So there's no point in walking into a branch and saying, I would like to close my account, right? And so you have all these accounts that are just idle, and you're trying to figure out who's going to come in and say, I want to close my account, but there's no point in doing that. So it's very hard to predict. But anyways, just a random musing, I guess. Here we go. But that's one thing that I have done. All right. So the end of the chapter talks about kind of ethical issues with data collection, legal issues. And I will say that, of course, there are very strict guidelines to data collection. I'll say especially in Canada. So, you have to have anonymous data. You can't store your data in the States, all these types of things. And so I want to focus on the ethical issues, mostly as an analyst, right? So what are we bound to do as an analyst? And I am really picky about, being really clear about what assumptions are you making when you're doing your analyses. What are the shortfalls of your report, right? What are the what are the gaps in your data? right? Some things you might not be able to explain. Did you have to remove data? Right? Did you have enough data? That kind of thing. And so those are all kind of ethical issues, I guess. So ethical issues, analytics professionals have a responsibility to behave ethically, which includes protecting data, right? We can't just be, a lot of people do still. So I was teaching at UBCO this summer, and they made you do like this whole, this is how we store student data, and it's so important and so important. And so it said, okay, when you're passing a grade sheet, so at the end of the term, you pass in a grade sheet to the admin, and then they have it on file. And it said you have to password protect it. So I did. And then I got an email like a month later saying, hey, I can't open it because it's password protected, which tells me that I'm the only one password protecting it. And everyone else is just sending it anyways. But I might be wrong, but I guess it's fine. It's just one of those things. You do all this training and you just have to try to follow all the rules that they give you. And in general, it's basically you can't share anyone's personal information, which is pretty basic, right? Especially something like their name and their grade. That would be just rude. Gone are the days of, I don't know if anyone was in school when you used to have to go to someone's office door. Everyone on their office door would print off the student number and then the grade. And then you're reading, oh, where's my student number? Where's my student number? That is so weird now. We're not allowed to do that anymore, right? But we did, they did at one point. I remember picking up my tests outside the office doors. Can't do that anymore, or we shouldn't do that, that kind of thing. So we're definitely more aware, right, than we were before. And that's just within 10 years, I want to say. Probably longer, but I don't want to do the math. So anyways, no, well, okay, a little over 10 years. Anyways, it doesn't matter. So what I'm sticky about is analysts must be transparent about the methods used to analyze the data and any assumptions that have to be made for the methods used, right? And so you have to be clear about how did you analyze it, right? And why did you use that method, right? And potentially, what are some of the reasons why your results might be unreliable, right? And any assumptions that have to be made for the methods used, and any reasons why your results might be unreliable. Okay. Instead of trying to hide it, it's better to be forthcoming and saying, oh yeah, here's what, oh, that's a good reminder that times I went overtime this morning, because 50 minutes, it's like, I hardly open my mouth. 50 minutes. So anyways, I'm sure you don't feel like that, but I do. So it's a good reminder. Okay, so of course, analysts are paid to provide valid conclusions and understandable recommendations to their clients. And so that's why we're making you do these kind of mini presentations where your client is not in this course, has not taken this course, is not taking any stats course usually, except, kind of a basic introductory stats maybe, but usually not. They don't remember anything. They just like to tell me that, oh yeah, I took stats and it was terrible. Oh, okay, cool. So anyways, so our job as analysts are just to provide valid conclusions and just kind of back it up with why, right? Why did I make this? Why did I use this method, right? What could be a problem with this method? And then I think the last thing I wanted to bring in, oh yeah, was just a fun example. And what a great way to end the class with just a fun example. So I guess there's a book called Weapons of Math Destruction, which is really funny, and I'll probably have to read it at some point. I didn't know, I haven't heard of that one, but author Kathy O'Neill discusses how algorithms and models can be unintentionally biased. Now, the problem that we see is bias. Well, we want all our data and all our analyses to be unbiased, right? They should just be, here's the truth, but it's really, really hard to avoid, right? And so here's just an example of things to look out for, right? So for example, consider an analyst who is building a credit risk model for awarding loans. The location of the home of the applicant might be a variable that's correlated with other variables like income and ethnicity. Did I say that right? Ethnicity. Why am I struggling on that? Ethnicity. It's time to end it. Anyways. So in your descriptive data, right, what you'll see is that, oh, actually where they live is highly correlated with, and here I go again, income and ethnicity. I did it. I don't know why it was so hard. Right? And so you think, oh, I'm just going to be clever about it, and I'm just going to use home location instead of those two variables, because what you'll find is you always want to have as few variables as you can in your model. You want to have the simplest model possible. And of course, that's for later. But in general, right, that would be a reason why you would choose to use home location over two separate variables. However, right, income is perhaps a relevant variable for determining the amount of a loan. Sounds reasonable, right? Should be the main thing to determine the amount of a loan. But ethnicity is not, right? And so a model using home location could therefore lead to unintentional bias in the credit risk model, right? And so it's the analyst's responsibility to make sure that this type of model bias and data bias do not become part of the model, right? You have to kind of think twice. But look at that, right on time. So if you have any questions, let me know. If you want help setting up your R&R studio, let me know. Otherwise, have a great weekend, and I'll see you on Monday.
Bye.
Thank you. Bye.